Welcome to Astronomy Daily, your source for the latest space and astronomy news. Today we have an incredible lineup of stories from across the cosmos. We'll be exploring everything from the mysterious sounds of Earth's magnetic field reversals to groundbreaking discoveries about black hole jets, and much more. Stay with us as we journey from our home planet to the far reaches of space, uncovering the latest developments in astronomy and space exploration. First up in today's stories. Every 450,000 years or so, something remarkable happens to our planet. Earth's magnetic poles completely flip. North becomes south and south becomes north. While this might sound alarming, scientists tell us these reversals appear to be harmless to life on Earth, though they're certainly dramatic events. The European Space Agency recently created a fascinating soundscape of what these magnetic reversals might sound like, using data from their Swarm satellite mission. The project focused specifically on the Lachamps-event, which occurred about 41,000 years ago. During this event, the Earth's magnetic field weakened to just 5% of its normal strength for several hundred years. Scientists at the Technical University of Denmark and the German Research Center for Geosciences transformed this data into an otherworldly audio experience. They combined natural sounds like falling rocks and creaking wood with more alien-like elements to create something that sounds both familiar and strange, as if some ancient force is stirring deep within our planet. The result was so compelling that it was featured as a public art installation in Copenhagen, where 32 speakers each played sounds representing magnetic field changes from different locations around the world. This unique project not only helps us understand these mysterious geological events, but also gives us a new way to experience and relate to our planet's dynamic magnetic field. What makes this particularly intriguing is that some scientists believe we might be overdue for another magnetic pole reversal. The last complete flip happened 780,000 years ago, well beyond the average interval of 450,000 years between reversals. Next up, in what could be a game-changing development for space exploration, researchers at the University of Illinois Urbana-Champaign have developed a revolutionary new propulsion system that could transform how we send spacecraft to the moon. This innovative approach, known as multimode propulsion, combines both high-thrust chemical propulsion and low-thrust electric propulsion while cleverly using just a single propellant. What makes this system particularly exciting is its remarkable flexibility. The spacecraft can switch between high-thrust chemical mode for rapid acceleration and low-thrust electrospray mode for precise orbital maneuvers. This dual capability system could significantly reduce the amount of fuel needed for lunar missions, while offering mission planners unprecedented versatility in how they move spacecraft through space. Unlike traditional hybrid propulsion systems that require separate fuel tanks for different types of engines, this multi-mode approach uses a single chemical propellant like hydrazine to power both systems. This dramatic simplification means spacecraft can be lighter and more cost-effective to launch, while still maintaining the benefits of both propulsion types. The research team has already demonstrated the feasibility of this technology for NASA-relevant lunar missions, particularly with small CubeSats. Their computer simulations show that multimode propulsion could enable these compact spacecraft to perform complex maneuvers that would be impossible with conventional propulsion systems. Perhaps most importantly, this technology isn't just theoretical. It's being developed for practical applications. The researchers have created algorithms that can automatically select the optimal propulsion mode for any given situation, potentially revolutionizing how we plan and execute missions between Earth and the Moon, and eventually to Mars and beyond. Moving on to our next story. Fascinating new research from the University of Michigan has revealed surprising details about the powerful jets emitted by supermassive black holes. By analyzing over 2 decades of data from NASA's Chandra X-ray Observatory, scientists have discovered that these cosmic jets behave quite differently when viewed in X-rays compared to radio waves. The team focused their attention on the galaxy Centaurus A, which hosts the closest known black hole jet to Earth, about 12 million light-years away. They tracked bright features called knots within the jet, measuring their movements over time with remarkable precision. One of the most striking findings was the detection of a knot, moving at an astonishing 94% the speed of light, significantly faster than similar features observed in radio wavelengths, which only reached about 80% light speed. Even more intriguingly, this fastest-moving knot was found in an unexpected location, neither closest to nor farthest from the black hole. The study challenges our previous understanding of how these jets behave. Earlier radio observations suggested that the fastest-moving structures would be found closest to the black hole, but the X-ray data tells a different story. This discrepancy between X-ray and radio observations hints at complex underlying physics we're only beginning to understand. These findings open new avenues for studying black hole jets, suggesting that X-ray observations might reveal unique aspects of these cosmic phenomena that remain invisible at other wavelengths. The research team is now planning to apply their analysis techniques to jets from other galaxies, hoping to uncover more secrets about these enigmatic cosmic features. The sun certainly got into the Halloween spirit this year, treating us to quite the spooky spectacle. On October 31st, a powerful X20 solar flare erupted from a sunspot designated as AR 3878, lighting up our star's surface at 5:20 p.m. Eastern Time. This wasn't just any ordinary flare. X-class flares represent the most powerful category in our classification system, with each one being 10 times more powerful than the M-class flares below them. The 2.0 rating indicates this was a particularly strong event, even within its class. The blast packed enough punch to cause significant radio blackouts across parts of the Pacific Ocean. When these powerful flares release their burst of ultraviolet radiation, they can temporarily disrupt our ability to use shortwave radio communications, which is exactly what happened in this case, reaching an R3 strong level on NOAA's space weather scale. Interestingly, while solar flares can often be accompanied by massive eruptions of plasma called coronal mass ejections, or CMEs, this event didn't produce one. That means we missed out on the possibility of seeing auroras in the following days, as it's these CMEs that interact with Earth's magnetic field to produce those spectacular light shows. However, space weather forecasters are telling us we're not done yet. There's a good chance we'll see more powerful flares through the end of the weekend, including the possibility of additional X-class events. It seems our sun is determined to keep the fireworks going well after Halloween. Here's a great collaboration story. Recent joint observations from NASA's Hubble and James Webb Space Telescopes have revealed an intriguing mystery surrounding Vega, one of the brightest stars in our northern sky. The telescopes have given us an unprecedented look at the massive debris disk that encircles this celestial neighbor, and what they found has left astronomers scratching their heads. The disk, which stretches nearly 100 billion miles in diameter, appears remarkably and unusually smooth. So smooth, in fact, that it's challenging our current understanding of how planetary systems typically behave. Unlike other similar systems we've observed, there's no obvious evidence of large planets carving paths through the disk like cosmic snowplows. The Webb telescope detected an infrared glow from sand-sized particles swirling around this brilliant blue-white star, which outshines our sun by a factor of 40. Meanwhile, Hubble captured an outer halo containing particles no larger than smoke, all reflecting Vega's intense starlight. What makes this discovery particularly fascinating is how it differs from similar nearby stars. Take Fomalhaut, for instance, a star of comparable age, distance, and temperature to Vega. While Fomalhaut shows 3 distinct debris belts, likely shepherded by planets, Vega's disk is strikingly uniform, with only a subtle gap at about twice Neptune's orbital distance from the Sun. This smooth, seemingly undisturbed disk suggests an absence of Neptune-sized or larger planets in wide orbits, unlike our solar system. It's forcing astronomers to rethink their theories about the variety and formation of planetary systems, proving once again that the universe has plenty of surprises left to reveal. While we await the arrival of NASA's Europa Clipper probe in about 6 years, space enthusiasts can now get an early preview of Jupiter's fascinating icy moon through NASA's newly updated Europa Trek web portal. This virtual exploration tool offers an incredible opportunity to soar over Europa's mysterious surface using compiled imagery from previous missions, including Voyager 2, Galileo, and Juno. One of the most striking features you'll notice during these virtual flybys are the dark lines crisscrossing the moon's surface, known as linea. Scientists believe these markings are actually cracks in Europa's icy crust, which flex open and closed as Jupiter's powerful tidal forces pull on the moon during its orbit. Interestingly, Europa's surface shows remarkably few impact craters, which tells us something fascinating about its age. While the moon itself formed around 4.5 billion years ago, its surface appears to be surprisingly young, somewhere between 20 and 180 million years old. This suggests that Europa is geologically active, constantly renewing its icy exterior. This virtual tour provides an excellent preview of what Europa Clipper might discover when it reaches its destination. The portal is freely accessible to anyone interested in exploring this intriguing world, offering both guided tours of Europa's major landmarks and the freedom to investigate the moon's surface independently. It's just one of many similar tools NASA offers for exploring various bodies throughout our solar system. Fascinating stuff. And if you'd like to check it out, I've included a link in the show notes. That wraps up our coverage for today on Astronomy Daily. If you'd like to stay up to date with all the latest developments in space and astronomy, be sure to visit our website at astronomydaily.io. There you'll find our constantly updating newsfeed, all our past episodes, and links to our valued sponsors. Don't forget to sign up for our free daily newsletter while you're there. It's the perfect way to ensure you never miss any important space news or updates. You can also connect with us across social media. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. This has been Anna with Astronomy Daily. Thanks for joining me today as we explored the wonders of our universe together. Until next time, keep looking up.